Hi, we are Arathi and Vinaya, and our project is on trying to understand the language of crisis open forums. Human intervention in crisis situations is an intensive work using a lot of human resources, and we believe using computing power instead to understand the situation would potentially lead to faster and more effective intervention. For our project, we try to automatically understand the imminence of suicide a person is expressing based on a post.
Our data is scraped from the suicide subforum of takethislife.com. We scraped the initiating post yielding 5,700 pieces of text. We crowdsourced labels using a web UI. The labels are in a scale of 1 to 5, 1 being suicide was imminent and 5 being had not yet contemplated suicide. We got almost 3,300 labels. The label data used a vocabulary size of about 38,000. Taking a deeper look at our dataset, we see several things. The left figure shows the frequency of each label, which indicates a heavy skew. The right figure shows a confusion matrix of the vocabularies of different labels, which helps us explore the basic differences in our label space. We had two broad classes of features for our linear classifiers, word-to-vec and handcrafted features. For our handcrafted features, we used bigram and unigram counts, plus fine-grained sentiment analysis. We also found data-specific features through manual analysis of our data, including appreciation, vulgarity, and seeking help. We ran several linear models on our data using our handcrafted features versus using word-to-vec. The figure shows the F1 scores of our experiments using 5-way classification. In general, word-to-vec performed more poorly compared to the handcrafted features. Our logistic regression model using handcrafted features performed the best with an F1 score of 0.28.
In addition to the linear classifiers, we experimented with two different neural network architectures. The first one is a simple two-layer feed-forward net, which takes in as input a concatenated pre-trained gloved vectors, runs it through a hidden layer, and uses softmax to output into the label space. The second architecture is an LSTM training on the sequence of words in each post. At each time step, the LSTM cell uses the embedding of the word and the previous hidden layer to compute the output. After a certain amount of time steps, which was tuned as a hyperparameter, it takes the hidden layer output of the time step and performs a softmax into the label space. Both models use the cross-entropy loss to train in backprop. Here are the results from the two models. We tried each of the models on several label spaces. Neither do particularly well on 5-way. However, LSTM does really well on ternary classification, and both do really well on binary, but interestingly, feed-forward does better than LSTM.
From our experiments, we found that the most effective handcrafted feature was using bigrams. We also found that using linear models, specifically logistic regression with handcrafted features, is particularly powerful, outperforming even the deep learning models for 5-way classification. Deep learning models, however, were particularly effective when the label space dimensionality was reduced to 3 and 2. We will be running the linear models on ternary and binary classification. We hope that further work on this project will aid counselors in crisis times.